Okay. Hello, everybody. And hello, Porter. So we have around 30 people tuning in so far, but we can get started anyway. For everyone tuning in, thank you for watching. Thank you for joining. We skipped last week, but most Wednesdays, I have the pleasure of hosting great guests across the Ethereum and ZK ecosystems and sort of like industry verticals to talk about really interesting technology, their views, and share their knowledge with all of you and also learn from them myself. So today I have the great pleasure of hosting Porter from ZKsync Matter Labs, who is a real expert in ZK and Ethereum. You may know him from some of the content he's putting out and great threads that he writes and all that. And I think we'll have a fun chat on how we can use ZK to save Ethereum and whatever else. Porter, nice to see you.
Good to see you too. Yeah, I'm excited. I won't be doing the dance to save Ethereum right now. I'm still practicing, but I'll come out in the next one.
Same. I think Quasi Matt and Kayla are going to be in Toronto for consensus, and I'm in Toronto, not for consensus, but because I live here. So I think I'm going to get roped into doing the dance, and I need to practice as well. But yeah. So Porter, I mean, I guess I met you 2 years ago in Denver, and then we spent some time in Montenegro. And this was before I knew anything about ZK. Like, I'd heard of it, but I really had no idea what it was. And I was also just getting deeper into understanding how Ethereum and rollups and these protocols work. So a lot has changed over the last 2 years. But you've been working on these topics for a while. So I am really interested in hearing how you got into all of this. Like, I know you have a math background, but yeah.
That's funny. I actually I joined ZKsync directly after the Montenegro trip. That's actually where I did my interview with Alex G, our leader, founder. And so I passed, thankfully. Yes, I was already excited about ZK back then. So I've always been a math person. I've always liked math. And the question was like, what do you do with it? Which I felt like it was always a silly question because out of all the majors or possible subjects I could pick, I was like, come on, mom and dad, this one seems pretty reasonable. I'm sure I'll find something to do with this subject. And so I watched one of those World War II movies with Alan Turing, and I saw him breaking the Enigma machine, and I was like, if I could do codes and code breaking professionally, I would, hands down, I'm in. And then I got super lucky because this whole field of crypto came along, and there's a bunch of cryptography math that's suddenly you can make a whole career out of. And so I feel very lucky and excited to be in this industry this time.
That's awesome. Yeah, I mean, you did it because you like math and you're passionate about it, but then the way that things went, it was good timing, I guess.
Absolutely.
Yeah, that's cool. So did you were you working on crypto specific things or research any of that when you were in school, or is that something you started exploring after you were finishing up? Or
yeah, I did a deep dive on, so I understood the cryptography side of things, hash functions were no problem, but I didn't understand why Bitcoin was worth any money. So I'm no early investor or anything. I was very still confused about the whole space. I first got into it because I was why can't you just copy paste and make more Bitcoins? Which to me was a very reasonable question. And then I figured it out, but I was still I don't know. So it wasn't until, really I was starting to graduate college and look for a job that I really got into the industry. And then I actually started as a Solana security auditor, which was super cool. Got to work with a lot of good projects over there. There are a lot of talented people. And then, from the Montenegro trip, ended up at ZKsync. And very happy to be on a full-time cryptography ZK project. It's amazing.
That's great. So at ZKsync, do you mostly focus on research? I know you definitely put out some really good educational content and things like reading through the entire code base of every zkVM, which is epic, and I need to watch those. But do you focus on research? Are there specific areas that you focus on?
Yeah, no one knows what I do for my job, which is super fun, and I kind of play into it maybe more than I should. I spent the first year actually on the security team, and so I never talked about it because security is a sensitive topic. If ZKsync unfortunately, if something terrible happened, got hacked, I don't want like people coming after me personally if like $1 billion goes missing. So like just keep low key about exactly what I was working on. About like a year ago now, they switched me to DevRel because we needed a little more like marketing, event presence, speakers. Besides, like we can't just send our CEO to every single event. We need some other people to go to and also give talks. And so, yeah, I've been doing DevRel for about a year, helping a lot of our builders, but also just like, yeah, helping people stay informed on like the ZKsync ecosystem. And then I've like been really interested in actually helping people stay informed in the Ethereum ecosystem too. So that's been fun.
And it seems like a really good fit for you as well, because I think a lot of people can feel your passion and excitement for the topics. So it's kind of the ideal situation. If somebody is not excited about the topic, it's hard to want to learn from them. But that's clearly not the case with you. So yeah, I mean, I feel like this is maybe a good time to start talking about Ethereum and ZKsync some more, because we're also like with aligned, like basically fully focused on Ethereum and growing this network and the way that people can access the trust that Ethereum provides, scaling Ethereum horizontally through rollups. And you guys have been putting out a lot of updates recently. I saw some big announcements. Yeah, what are you most excited about, or what would you like to tell people about? Because I know you have like a new VM that's coming out. I'm curious about that. And
There's several huge tech announcements. Like I think from January until like probably end of this summer is like the biggest wave of tech upgrades ZKsync has ever had. I will just start with the number one biggest one, and if you only remember one thing, this is the takeaway, is that ZKsync finally has added full EVM equivalence, which, yay, we did it. But for a long time, yeah, building on ZKsync was like not quite the same as building on Ethereum. You could still use Solidity, but you had to use like custom compilers. You couldn't use Foundry. You had to use ZKsync Foundry. And a lot of little things that are kind of painful. But now you can pretty much just truly copy paste onto ZKsync. Everything works, and so yeah, we are very excited to like finally have the full EVM working.
that's awesome. And I guess most L2s aren't like fully EVM equivalent, like ZK EVM L2s.
Most of them are. We
Okay.
were, I'd say Starkware is the big exception. They
Mhm.
have gone a completely different path, the unaligned path. And then because we built so early, we had to like make optimizations for ZK. But now like ZK as like a technology has gotten so much better that it's fine to prove the entire EVM. It's not nearly
Gotcha.
as it used to be.
Yeah. Like I only really started digging into this specific topic in the last year, and before then, it seems like things have gotten a lot simpler with like the VMs now. Just prove the whole, prove all the execution. But there were a lot of tricks you had to use before to make it possible, right? So okay, awesome. And that's live. That's already out there. You
That's
can
something
copy
that
and paste your contracts from Ethereum and stick them right into ZKsync.
But I should
Okay.
clarify, there's multiple ZKsync chains now. Era is the first one that everyone kind of knows and assumes. EVM
hmm
equivalence is live there. And then there's a bunch of other ZKsync chains like Abstract. They just added EVM equivalence. And then like some of the others are still doing the upgrade. But like the upgrade's
hmm
now, probably in the next week or two, everyone will have it.
Okay, cool. Yeah, so ZKsync Era is like the main ZKsync chain, the original one, but there's also a bunch of other chains that are using the zkStack that are part of the like Elastic network, right? You mentioned Abstract.
Nailed our terminology. Our marketing
Yeah.
department would be so happy you said all those words correctly.
Yes. Shout out ZKsync marketing. I think you guys have done some good marketing. I like Elastic Chain. I think it sounds great. The ZK is the end game sort of thing was really good. But yeah, so all the chains using the same stack, like there are interoperability benefits, correct? Like that's something I haven't looked into. I'm kind of interested in hearing more about
Yeah.
that.
There's right now interoperability has gone from like every L2 is a completely separate thing to like these clusters of L2s. And so you have like the ZKsync Elastic Chain cluster, there's the Optimism Super Chain cluster, a lot of people know. And then like there's a couple other solutions. Not everything cleanly fits into the cluster solution. Like AgLayer says there's like some technical differences, but basically they're becoming groups of chains that are interoperable. And for this, like for two chains to trust each other, they need some way of knowing that the other chain is like behaving correctly. And sort of the more they know about the other chain, the easier this is to do. So if you're like running basically the same software version and proving with the same proofs back and forth, that makes interoperability like way, way, way easier. If you have two chains that like don't know as much about each other, you can probably still force some form of interoperability, but it's going to be like a little more difficult and slow.
Mm-hmm. So do you get synchronous composability between
it might be like slightly asynchronous, but it's going to be like 2 seconds or 1 second.
Okay, so it's like fast asynchronous.
Yeah.
Cool. Yeah. There's been, I think, a lot of like debate around the importance of synchronous composability versus asynchronous composability. I remember a lot of people were discussing this in Denver, and it's something that I haven't gone too deep into, but there seem to be some strong opinions around it. Like people saying you don't actually need synchronous composability, but then maybe at like a very deep protocol level for liquidity and like and everything else, then you do want that. I mean, yeah. Do you have any thoughts on synchronous versus asynchronous, like big picture?
I think like the way some teams are doing synchronous composability is basically just using a bigger computer and just running a node for every chain all at once. And at that point, like you're kind of just using the same sequencer for every single chain, which is fine and works for like a small limited number of chains. But if you want there to be thousands, like I'm not running thousands of nodes for everybody else. Like base chain is not going to run Porter chain's node, no matter how much I try and talk them into it.
So, what if you give them a huge grant?
yeah. Large token allocation right now. And so that's kind of where like some of the different approaches are coming, where like if you have like maybe 5 chains that really want to work together, yeah, you can get completely seamless like interoperability. Once you start talking about even 10 or 100 or 1,000, that's where like you probably won't have seamless interoperability anymore, and that's kind of what ZKsync at least is aiming for at first. And if on top of that you still have like maybe 5 ZKsync chains want to do synchronous composability through like a shared sequencer, they're welcome to. Like you can still kind of add that in on top. There's nothing stopping it, but we want something scalable, and ZK does that.
Yeah, totally. I mean, I guess this also makes me think about base rollups because, you know, then the idea is we'd have synchronous composability because the shared sequencer is like the L1 itself, right? Is that something you've explored yourself, or have you guys been thinking about this?
I've tried looking into it like a couple times, and I had a call with M-Team who also tried to explain some things to me. And so I understand completely like the Tycho, just like completely permissionless, just like whatever gets posted to the L1, that is the sequence. The challenge is there's only an L1 block every 12 seconds or so. And so what do you do in the meantime? And what they're working on, everyone, is pre-confirmations. So if I submit my transaction now, within maybe 1 second, they say you're good to go, even though it won't be posted to Ethereum for several more seconds. And the important question is, like, who's saying you're good to go? And like, who's checking that? And so some of them are adding kind of this layer that's like, not officially the sequencer. It happens before it gets to Ethereum, though, and they're making the big promise that it will be sequenced later. And right now, the architecture is pretty complicated, and I wouldn't say I understand all the details and trade-offs, but my big hesitation is just the, like, now it doesn't quite seem like you're fully on Ethereum. Like, if like, let's say, you know, Vitalik's running his Ethereum node, if you're doing this kind of, like, off-layer sort of, like, pre-confirmation thing, like, Vitalik's not pre-confirming my transaction at all. Vitalik doesn't know yet. So kind of who is? I don't know.
Yeah, there's like a new trust assumption added somewhere, but I guess if it's designed properly, then the economics should work, right? No, you're not going to, if you break your promise, there's going to be a penalty. But yeah, I know there's a few competing designs for pre-comps that are all kind of in active development that people are testing. But I guess maybe if Ethereum block times decrease and we have shorter block times, this becomes less of an issue. And how I've kind of thought about it, at least, is like as Ethereum scales and the L1 gets higher throughput, higher gas limit, faster block times, single slot finality, then base ropes would seem like a more attractive value proposition, because they would just be inheriting those properties from the L1. But
Exactly.
that might not come super soon. That might take some time.
Yeah, like the Justin Drake pitch to me originally for base rollups was like, we have these L2s, they're all single sequencer right now. We want them to decentralize their sequencer. And then like, what's the most decentralized sequencer in the world? It's Ethereum L1. And so she used Ethereum L1. And like, just the little high level steps, I'm like, yeah, it makes total sense. So I'm like still on board the base rollup chain eventually, probably. I just like haven't quite seen how it's going to work yet. And so, at least for now, this is another cool update, is the ZKsync is decentralized in our sequencers, but just with normal consensus algorithms. So not in a based way.
Okay, yeah, that's so when you say the sequencer is decentralized, you have like a network of nodes that collectively act as a sequencer, and then there's a separate consensus algorithm that's running. Is like, are you able to talk about how that works? Because that sounds interesting.
Yes, I have an overdue YouTube video I'm supposed to make on how it works, but we made our own consensus algorithm called ChunkyBFT. I love the name, and yeah, we picked like a couple good properties that like Ethereum's even trying to work towards, which we have the benefit of building second, so we can kind of learn from what's good. So things like single slot finality turns out to be like super important for DeFi applications. And so that's like one of the properties. Another is, yeah, just like figuring out that communication overhead's like actually not too bad. Like sending packets around on the internet's like not as important. So it's fine to send more communication between all the nodes than like, and get better properties like one slot, single slot finality. So that right now it's in progress. There are like, I think 5 or 10 nodes running ZKsync Era's like sequencer together. The problem is it's not permissionless to join yet. So what we need is like a staking solution where if you stake your tokens, you get to be the sequencer for a little bit. And so that's
gotcha. Like a sort of like a leader is elected, and everyone else agrees that the sequencing was good. So you can actually still have like good performance, I guess, is the idea. But you need some economic stake. Cool. So, but I guess the idea longer term is to allow anyone to be able to participate in this and add some stake. And cool. Yeah. Right now, I guess you have some partners and other teams that are participating, testing this out.
Yes, some of the ZKsync chains are definitely asking for this, and I'll let them do their announcements when they want.
Okay. Cool. That's awesome. Yeah. I mean, I understand the trade-offs that are made often in terms of like centralization versus decentralization to achieve performance and actually have like systems that work. But I personally really like to see that teams actually are like progressively decentralizing and improving this infrastructure, and not just like leaving it as it is and saying like it's fine. We'll just use the centralized thing. So that's really cool to hear.
It's extremely funny and interesting to watch like who cares the most about decentralization, like who's asking for the decentralized sequencers, who's asking for decentralized provers, because some of it is like, you know, some of our like consumer chains who are just like very end user focused, and they just want to kind of for like the community and stuff to like help spread out the chain. That's awesome. That's probably not who like most people would have predicted is like the most cypherpunk is like the NFT people, you know?
Yeah.
And then on the other side of it, the like bank chains also have like really asked for super strong security properties. And it's so funny because like we were trying to do the whole, you know, bankless thing, and then these banks come along and we're like, actually, we do want to put the whole financial ecosystem on crypto rails, and we need it to be like as decentralized as possible.
Yeah.
Oh, all right. Let's do it.
Yeah, that's who I was also kind of thinking would be, I don't know, the driver of those sorts of demands, or like who wants those security properties, because decentralization is security, it's censorship resistance, and like if a bank is going to use Ethereum as like its financial rails or like back office kind of back end, then it needs to be secure, it needs to be verifiable, it needs to be like live all the time, and decentralization helps with all those things. But yeah, I hadn't thought about the sort of like NFT communities, for example, which are thinking like, I think a lot of people got into crypto partially because of the idea that you can have sovereignty over digital assets and actually own them. But then if you rely on some centralized service, then that kind of goes out the window. So yeah, that's really cool. Yes, cypherpunk NFT communities, let's go. That's very cool. So you also mentioned the prover, right? Like decentralizing prover. I know you guys have multiple provers, and Firma is generating proofs for ZKsync now. How does that setup work? Like,
yeah, we're also working with Lagrange. Not quite sure how it's going to work out eventually, but yeah, basically I'll say historically the only people really running the prover are Matter Labs. The code's open source; anyone could do it, but like it's not just having the code. You actually need like a lot of DevOps experience of like coordinating these different machines, and like a lot of times it's not like you're just slamming. You probably know this from a line to two. You're not slamming the whole proof through like one machine and you wait 5 minutes and it's done. Like you're kind of doing like a piece here, kind of coordinates back. You aggregate those two pieces together, and then like that's it goes to another machine. And so, and if you try and like slam all that through one machine, you actually get a lot of inefficiencies and higher costs. And that kind of like harms the whole chain and the user experience and everything. And so, yeah, we've been working very closely with some of these prover networks to decentralize the proofs, which should hopefully, one, like add more security properties, but two, yeah, we're working with them to make sure that the costs stay like very low, and that we're making it even easier to run the ZKsync prover, which is very important for decentralized.
Okay, sweet. Yeah, so when you say like a decentralized prover, is it actually that proving is happening across multiple, like, well, I guess you already said that, you running the prover is not just one big box, you're doing some orchestration, and it's sort of like multi-threading in a sense across multiple machines. So when you say decentralizing proving, is it just going to be multiple entities all competing to generate the proof, or all generating the same proof so you have redundancy? Or is it actually like splitting this one proof across multiple entities?
There's several strategies, and I think it is somewhat up to the prover network teams and like exactly what we'll end up going with. I think the plan is to basically have, here's like a batch of transactions. ZKsync needs a proof for them. We will send that whole batch to the prover network, and then the prover network will abstract everything, handle everything. But internally within the prover network, what they're going to do is probably they're thinking about like either running like an auction or something, and then selecting, saying like, here's one person who's like kind of won the right to go do this. Because if you let everyone compete for it, either like if multiple people try and generate proofs, like somebody comes in second place and doesn't get any reward and probably like wasted a lot of computer time, which is not great. And so yeah, we're probably running auctions or some sort of like election cycle where we'll say, all right, Boris, it's your turn to run like the proof for this batch. You have like a maybe 1 hour window. If you don't come back to us with it, or you sign up first, so you agree, you say, yes, like I'm ready to do this batch. And that's kind of like, you'll stake some amount for that. And then if you don't come back to us within an hour with a proof, then like we might slash your stake because you're kind of slowing us down. And we set the time windows and the stakes to like be appropriate for the situation. But
Yeah. Okay, it's interesting. Yeah, I mean, I've sort of looked into Boundless and how they've been doing this kind of like auction for mining proofs, because like you said, yeah, it's. I mean, my understanding is that really, if you just have more GPUs, you're going to be able to generate proofs faster. So in this situation, it's like the fastest computer will always win, and it's like a winner take all situation. So you need some way to make sure that proofs get delivered, and there's like some economic bond or stake that ensures this to some extent. So, okay, cool. And then I guess there's also other participants in this decentralized proving network. So that way, if the first person chosen fails, somebody else can do it.
Yeah. I will say an interesting question is like, especially as Ethereum's trying to prove like Ethereum blocks in under 12 seconds. So there's a big race to get under 12 seconds, but no one's worried that much about like how many computers they're using or how many GPUs you're using. So if you could just throw like 10,000, 100,000 GPUs at a single Ethereum block and get it under 12 seconds, like people will go post on Twitter, huge marketing win, we've done it, real-time provers here.
Real-time proving has been achieved internally.
I actually think these teams are going to hit that in like the next month or two. Like people are very close. Like they're at like 24 seconds now, I think, from RISC-V, and they need to get to 12.
I saw that. Yeah, I saw them say that the other day. They're 22 seconds to prove a block. I mean, I don't know which block it is, but yeah.
I just know at ZKsync, when we prove our blocks, which are now EVM equivalent, we don't choose the biggest provers in the world and we don't choose the biggest GPUs in the world. We choose like cheap GPUs that are like efficient, and we use like a very reasonable number of them. And so the job gets done in a slightly longer time, but that's like the most cost-effective approach.
Yeah.
And so I do think before we can really include these in Ethereum, we're going to need like to have the both 12 seconds and somewhat reasonable number of GPUs and costs being used.
Yeah, exactly. If you need a supercomputer to prove these blocks, then it's a little bit. It doesn't really it doesn't really scale. It's not really that useful for decentralization. Yeah, that is a good point. So with your EVM equivalent blocks, like could you compare gas with like actual L1 blocks? Or
I just saw an Ethereum EF like researcher post about this, where all like L1 gas prices are charged in terms of how expensive is it to compute that operation on a normal computer. And then when you try and like ZK proof things, there's like a totally different set of operations that are like cheap or expensive for ZK to prove. And so we're gonna have to like pretty severely rebalance gas costs for the L1 if we do try and ZK prove everything.
Interesting.
Because like maybe hash function's actually not that bad on normal computers, because a lot of chips these days have like built-in SHA-256. But as soon as you try and like ZK prove that, and you've got like binary XORs trying to be proved over like a prime field or something, like it gets ugly and really hard to prove fast. So
interesting. That's something that I mean, I'm not that deep into the engineering, but I hadn't thought about this, like needing to rebalance gas or opcode costs or something based on like the L1 being fully snarkified and like beam chain proposal. Okay, something to think about. I've been started going to the ETH proofs calls to try to follow everything. I think there's like 12 zkVM teams right now. Or more. Or yeah. A lot of code bases for you to go through.
Yeah, and people keep rewriting them too. I don't think I'll ever fully finish.
Yeah.
I've delayed my streams. I did a bunch in like January and February, and then leading up to Ether, and then I've been waiting because ZKsync has Boojum 2 coming out, which is completely like new proof system, not related to Boojum 1 except for the name. Like we've rewritten everything from scratch, but Boojum 2 is like a RISC-V zkVM. And so part of why I'm doing these deep dives is people are going to ask and want to compare, like, you know, what's with your proof system? Aren't there like 20 others of these things? And so it just seemed like a good excuse also for me to go learn everything and check out what everyone's up to.
No, totally. Like, I think I've spoken to you about the benchmarking that we've been doing. We haven't updated that too much lately because we got the information we needed for what we were working on, which is our aggregation service. That we have on, I don't know if you saw this, but we have it on testnet now, and we have RISC-V and SP1 integrated. So you can use aggregation for those with Aligned. And that's part of why we were doing the benchmarking, but also to learn and understand all this technology better internally. So we're also going to be putting together a new website because we bought some domains a little while back. So we're gonna have like a zkVM information site where we just like try to compile all the info about the zkVMs in the market. So at some point, I'll probably be bothering you for some details on Boojum too.
Let's do.
Yeah. Oh, what else? Like, so Boojum 2, is that it? That's in development right now.
Yeah, it's getting to the end of development. We're starting to get audits on some sections of it, and yeah, we've been aiming for like it being on mainnet at the end of this summer. So
Okay.
I think we're still somewhat on track for that.
Cool. Exciting stuff. Oh, I remembered what I wanted to ask about. And this is a little more technical, and specifically for ZKsync Era, because I was trying to do some estimates, just like back of the envelope calculations around verification costs. So I was like digging into Etherscan and trying to figure out how many proofs are being verified with what frequency, like how much each of these verifications cost like in terms of gas. And I found an article from Nethermind Research, I think, from like last year, where they did some comparisons of like user operations versus gas and all this. But I'm curious, like with Era, how often do you like prove and verify, and do you do any aggregation sort of in between to reduce those costs? Like I couldn't find it really clearly in the docs, and a lot of people probably don't care about that. So.
Yeah,
But
it's literally my job now to write those docs. So just let me know. I'll go update it. But, so it's actually an answer that's changing. So historically, like everyone knows, ZK proofs scale. The more data you shove into them, like the better sort of everything gets. And so we have basically transactions are coming in, and then at some point we decide to close a batch. We say, like, here's the end of the batch. We're going to prove all of these things at once. And there's several different metrics we have for, like, at what point do we close the batch? So, like, how much pub data is there that needs to be, like, put into blobs? That's usually how we end up closing batches, is like, okay, we've filled up, like, 1 blob's worth of data. We should, like, close the batch now and just, like, make that proof. There's a couple other metrics like maximum gas usage, or like maybe maximum transactions, but I think we always run into like one of the other like maximum limits first. But anyways, yeah, so then once we close the batch, it gets broken down into, in Boojum 1, we have like 13 different types of circuits. There's like the main circuit that does most of the stuff, then there's like the SHA-256 like specific circuit and a couple others. And so yeah, the batch kind of gets pushed through all of those. You end up with like 13 different proofs, and then we would like recursively aggregate this together. And then at the end, we slap a snark on it so that it can be, we use Plonk at the end. So we can verify on Ethereum with a Plonk verifier.
I see. Okay.
Just recently, actually, we've changed to a FFLONK verifier. So FFLONK. I don't know how to pronounce it.
FFLONK.
Yeah.
Yeah.
Like a hard double F.
Yeah, like FFLONK. That's so. Why did you change the? So you're wrapping the proof at the end, right? Into a snark, because that's cheaper to verify. Is FFLONK cheaper than Plonk as well?
Yes.
Okay.
So it's more work on the prover side, but basically the comes from the fast Fourier transform. And with normal Plonk verifier, I need to look into details. This is probably one of my worst ZK explanations, but my understanding is there are like 6 polynomials beforehand, and then you do like a fast Fourier transform and combine them into one really big polynomial, and then verifying one large polynomial is easier than 6 smaller ones.
Okay.
So we're seeing about 30% gas savings with FFLONK.
Okay, very cool. That's a lot of savings. I mean, do you know off the top of your head how many gas units it is to verify that?
I do not.
No, yeah, that's fine. Yeah, I'm curious. Like I need to figure out a better way to get this information on chain, because like going through Etherscan and like digging around and being like, there's like this diamond relay or proxy or whatever, and I'm like, okay, is this what I should be looking at?
I can go find it. The team definitely knows. I just don't know off the top of my head.
Yeah, no, it's fine. It's something that I was like, up way too late at one point a couple months ago, just like digging into this research, being like, there must be a better way to find this. Okay, cool. That is exciting though. Yeah, I know verification. Well, obviously that's what we've been talking about a lot. Verification being expensive and a bottleneck. So it's cool to see that even like without other solutions, you can already just optimize the proof to be more friendly with Ethereum. Sweet. Okay. And I want to ask you one last thing. I don't want to keep you too long, but I mean, at least from my perspective, looking at Twitter and talking to people, it does seem like there's been a lot of effort going into like Ethereum overall, like the L1, prioritizing things, upgrading it. There's been a lot of discourse around this, which at least I personally find very interesting, and I think a lot of people on like crypto Twitter find it interesting. Sort of like end users, consumers, maybe less so, but I think the research culture around Ethereum is one of the things that drew me in and keeps me here. But yeah, like Pectra went live, and there's been all this conversation around how to improve the L1, scale the L1. I'm curious what you think. Like, are there things that you've really been happy to see? Are there things that you think are still being kind of ignored or sidelined in this conversation? And how is ZKsync looking at Pectra as well?
Yes, I think in general, we're very excited that the L1's like making improvements. Like for ZKsync to succeed, we really want Ethereum to succeed too. So people get confused. They're like, if they make Ethereum faster, like, do you still need L2s? And the answer is yes. Like, even if Ethereum gets 10 times faster, like L2s will probably also stay 10 times faster than that. Like, and so we don't mind it at all. We're actually very encouraging, and I think actually a lot of L2 teams are some of the ones pushing for the L1 to improve, like to have better gas costs, have better like more blobs, and so yeah, in general we're very excited. I think Pectra was pretty awesome. I'm like amazed every single time we upgrade this machine. Like it's the most, it's insane. 10 years of flawless like upgrades is wild engineering work. And so specifically account abstraction, I think is a very big deal. I think that's going to help with a ton of user like experience issues and things. I mean, like the Mimi one is the like approve and send transaction, like double signing, and that's gone now. And in general, like there's a lot of cool things you could do. Even like I'm a big fan of ZK email and account recovery, which like you can now send an email and then like reset your seed phrase basically, and your account abstracted like smart wallet will just like move your funds to your new account for you with like upon acceptance of a valid proof of an email, which is super awesome. That like we could have that sort of like Web 2 password reset with your email experience in Web 3, because so many people seed phrases, and that's just like one of the really cool like user experiences that comes with account abstraction.
Yeah. Did ZKsync had some account abstraction stuff already from what I can remember?
We've had it like since Era was created, like 3 years ago, two years ago.
Yeah, like I played around with it a long time. I also played around with like ZKsync Lite, like the sort of like earlier version. Yeah, a long time ago. Just downloaded. I forget which wallet it was. Argent maybe, or is that the Starknet one? Anyway,
I actually didn't use Lite. I was not.
No, I didn't really use it. This is really before. This is just when I was getting into crypto, and I had like like $5 worth of ETH or something, and I just like bridged it over, transferred it over somehow, or use a credit card. I don't know, but this was before I even knew what like an L2 was, to be honest. So I was just like playing around with things. Yeah, I think email account recovery is really cool. Like Pectra and the UX improvements are also what I'm stoked about. I do kind of wonder, or like something that I'm a little concerned about myself is if account recovery is based on your email, then the like security risk really goes to like your email, because if somebody can take over your email, then they can also steal your accounts. I'm sure there's ways to construct.
You want to do like 2 out of 3 with multiple email providers.
Yeah.
And I think like the people who are going to use email reset are probably not the power users anyways. So
Yeah, that's a good point. No, I mean, I think like crypto UX has improved so much over the past year and a half even, and a lot of the UX problems that, I mean, I've gotten used to the bad UX by now. Like, I'm happy to use MetaMask. I bust my ledger out. I'm like using my own multi-sigs, but it's not good UX. I've just gotten used to it. But now, like universal embedded wallets like Para or Privy, this is like, I was onboarding a friend recently, and it was just like, he's like, oh, I had to find the seed phrase because I got a new laptop because I helped him set up a MetaMask years ago. And I was like, dude, just use this. You just sign in with Google, and I can send you, I can send you some stuff. I can send you some USDC. And he's like, oh, this is so much better. He's like, I don't need to remember the seed phrase. I'm like, no. Just like make sure no one hacks your Google account. So yeah, I'm excited for all this as well. And yeah, I wanted to just echo your last note about L2 teams being excited about the L1. I think that's important for people to realize that like the L1 getting better is good for all the rollups, because then they can also scale more and they can like provide a better product to their users with lower transactions and more security and everything else. So I'm not surprised at all at your answer. I'm just like giving a +1, like, yes, totally.
actually, I want to do my L2 pitch quickly because this is something that I think a lot of people haven't. Or I've spent too much time thinking about it, so I need to share.
Yes, let's hear it.
Like the question is like, how much TPS do you really need? So like, let's say for the whole world, let's say you have like a really narrow mindset, or like it's just say Visa's enough for the whole world, and that's 75,000 transactions per second or so. And if we could have one blockchain like that gets to that, then everything like would work, and we'd all like be great. I actually think even if you had that blockchain that like miraculously had like infinite throughput and could handle everything, I think people would still choose L2s sometimes, just because like the same reason we don't run every single website on the same like supercomputer web server. Like, there's something just kind of nice about like having my own L2, my own website. It's customizable. I can like use it how I want. An important problem that I think people don't think about enough is if you have everything running on the same blockchain, like those nodes that keep track of the data have to keep track of the data for the whole world. But if I'm running like a tiny little startup in a small project, I only want like a very small fraction of the data. And so 99% of like my node is like not helping me. And so it's kind of inefficient from like an app developer's perspective to have to like share a chain with everyone else. It makes a lot of sense to just try and run your own chain. You only need to use the resources that you need for your app, and you can customize a lot of things to be how you want.
Yeah.
And so I think like the customizability of L2s will be an extremely important thing in the long run, even more than like I think scaling at some point, we probably do get close to like everything's just scaled so much we don't talk about it anymore. But even in that world, I think there's still a need for L2s.
I love that. That's a good perspective. And yeah, I think like we're still early, and there's going to be a lot of space for different L2 designs, depending on what the user needs. That makes total sense to me, honestly. And then the nice thing is you can still get security from like Ethereum, while having your own customized verifiable server, a roll up for every household and every company.
For every person.
Yeah, exactly. Oh yeah, there's people working on that for sure. Yeah, and then last thing, it kind of reminds me of like Maiden in some ways. I've been looking into that a little bit, and it's like super interesting how like it's a roll up, but then every user is almost like every account is kind of its own roll up. So you can have these private peer-to-peer transactions that then get settled to the like main roll up, main Maiden thing. Really interesting designs, and there's other stuff too. Like I feel like there's so much space for exploration around blockchain still, and I'm beginning to appreciate it as I learn more and get deeper into it all. So Yeah,
my
yeah.
live streams.
Yeah, exactly. I got to watch more of your live streams, and that what you just said, your L2 pitch, I think is going to make an excellent short clip, so we can share on Twitter, and we got to start putting those on YouTube. But yeah, Porter, I don't want to take up too much of your time. Do you have any like last things, calls to action, things you want people to check out? Like everyone watching, make sure you actually follow Porter. He posts really good stuff. But aside from that, any like closing thoughts?
Just the big one for zkSync is that we added EVM equivalence recently, and so you really can just like come copy paste your app now. Building on zkSync's super easy finally, which like after all these years we're super excited is here. So that's the big one, is come build and say hi anytime. Also, if you have like any questions about anything, yeah, I'm around on Twitter. Thanks, Boris.
Thank you, Porter, and thank you everyone for tuning in. If you have thoughts on who you'd like to see on these streams, feel free to reach out and let us know, and we'll see you next time.